Okay, I want to talk today about the way we multiply whole numbers in fourth grade and how that can help us multiply fractions and mixed numbers in fifth grade. If I were to multiply 52 times 71 as a fourth grader, I would likely use an area model and probably decompose the 52 into 5 tens and 2 ones, and the 71 into 7 tens and a 1. And then I would complete my area model, 3,500, 140, 50, and 2. Then I would take my partial quotients. Those are products. I'm sorry, we've been dividing all day today, but now I'm wanting to multiply. We're going to take our partial products, and I'm going to find my final answer. 50 and 2. So that would give me a product of 3,692. Okay, that's pretty straightforward. That's what most of us are doing to teach multiplication of these larger numbers in fourth grade. So what's come over me in thinking about multiplying mixed numbers and fractions in fifth grade is that it's hard. It's always hard, and how can we make it easier? And so I actually did something crazy. I read the standard, and the standard says that we should apply and extend previous understanding of multiplication. Okay, now, if I were going to work this problem, or teach kids how to work this problem, I would say, all right, and most of us would, we're going to take this and we're going to change it to an improper fraction. So that would be 8, 9, 10, 11 fourths times 32, 33 eighths. Okay, and so now I'm going to have to multiply. Geez Louise, what have I gotten myself into? That should be a 3. All right, 363, and that would be 30 seconds. And then we're going to have to change that back then to a mixed number. This is some nasty division too, because these multi-digit divisors are new to a fifth grader. All right, so let's see. And of course, they wouldn't be likely doing the standard algorithm for division, even if they had instruction on this. All right, so there's my product, 11 and 11 30 seconds. All right, and so I guess the thing about this is it's what we've all done, but it really doesn't extend any previous understanding. It's a completely new skill. So how can we, and I hope I can keep all of this in the frame, but I'm going to try. How can we work that same problem, extending some previous understanding of multiplication? So what if I take my 2 3/4 and my 4 1/8, and I use that area model that I got really good at in fourth grade, and I just decompose the fractions, because hello, fractions are numbers too. All right, so now I've got something that's familiar and not quite as nasty, because we've multiplied whole numbers and fractions in fourth grade. 2 times 1/8, well, that's 2 groups of 1/8. Hello, that's 2 eighths. All right, 3 3/4 times 4, well, that's 4 3/4. So that's going to be 12 fourths, and hopefully I might recognize that that is in fact 3. Okay, and then I'm going to multiply 3/4 times 1/8, which is going to be a new skill for fifth grade. So they will have had to practice fraction by fraction before you get to this. Okay, so now I have these partial products that I'm very familiar with from working with them in fourth grade. And so now I can add my wholes. That would give me 11. Now I need to add the fractions, but I recognize that I have different units here. So I think what I'll do is I'll get my 2/8 into 30 seconds so that I have the same parts. So that would be, let's see, times 4 to 8, 30 seconds, right? And then 8 30 seconds and 3 30 seconds is going to be 11 30 seconds. Which is the same thing that I got, if you can still see over here. But this, in my opinion, is just not quite as nasty, especially because we're using something that the kiddos are already familiar with. So that's my suggestion to you. Work smarter, not harder, and let's use a strategy that kids are familiar with.